everyone, in this video we will discuss all the reasoning question related to the physical and chemical properties of D and F block elements, and these are a very important question and they are frequently asked in the CBSE board exam. Now the first of the main question is, what is the electronic configuration of D block element, or why zinc, cadmium or mercury do not considered as an transition element? So the key word for this answer is the electronic configuration is 4s2 3d 1 to 10. And what are the transition elements? The elements where in its atomic and ionic d orbital is partially filled. But in case of zinc, cadmium and mercury, the d orbital is completely filled in its atomic as well as in ionic state. Hence they are not considered as a transition element. Now one more question related to the zinc, cadmium, mercury, that they are very soft, or we can say their melting point is low. So reason again lie in their electronic configuration, because they have completely filled d orbital and hence there is no unpaired electron, therefore no metallic bonding will take place, hence they are very soft. So now again one question can be framed, why few elements possess a strong metallic bonding? Because they have contained unpaired electron. Similarly, as we move along the period, unpaired electron first increases and then decreases. So again we can say melting point first can increase and then starting decrease. Next important question is related to the atomic radii, that what is the trend of atomic radii in the transition element. So you can see here, it first started decreases, that become constant, and in the last increases. So there are three different reasons for these 3 points. So initially decreases, why? Because of increase in effective nuclear charge, but in between they remain almost constant because of the screening effect is counterbalanced by the increased nuclear charge. So the increased nuclear charge is just counterbalanced by the screening effect of the inner electrons. Then in the last it started increases because of the electron-electron repulsion, due to which expansion of the electron cloud will take place. So for 3 different positions, 3 different reasons are there. In general, atomic radii along the period decreases. This is a general trend. You have already done this in class 11th. But for the D block element, the trend is different, that first it decrease, then remain constant and then increase. So you must know the reason for all these 3 factors. The next question, why D block element possess a variable oxidation state? Now because Ns and N-1D have similar energy, or we can say their energy is nearby same, hence they can easily show, or D block element can easily show a variable oxidation state. Now since they can exist in a variable, it can possess an highest and the lowest, and the lowest oxidation state is basic in nature. Now the question arises, why lowest is basic in nature? Because metal can donate a valence electron which are not involved in bonding if it possesses a lowest, hence it will act as a base. Again I am repeating, why the lowest oxidation state act as a base? Because they have a lone pair which is not involved in bonding and hence it can be easily donate, hence they will act as a base. Whereas the highest oxidation state, they don't have any lone pair or an extra electron to donate, but yes they can accept, hence they are, we can say, acidic in nature. So valence electrons are involved in bonding and hence not available for donation, therefore highest oxidation state will act as an acid. Next question is a very important, related to the magnetic properties. If an element contain an unpaired electron, it is a paramagnetic. If it contain a paired electron, it is termed as a diamagnetic. And then how we can calculate the magnetic moment? It is under root n plus 2, where n is the number of unpaired electron. So for this reasoning question, you must learn the electronic configuration of 21 to 30 element of the D block, and always remember that pairing will not take place until and unless each orbital is singly filled. So for example, in case of manganese, the electronic configuration is 4s2 3d 5. So there will be 5 electrons. So what will be the magnetic moment in that case? 5 plus 2 7, 7 into 5 35, and under root 35 is the root of 5.9. So for chromium it is 6 unpaired electron. So 6 and 6 plus 2 8, 8 6 for 48. So under root 48 will be 6.9. Now how it becomes 6.9? 7 7 49. So less than 7 will be the answer, that is 6.9. Now in next case there are 5 unpaired electron. So it is 5 plus 2 7, 7 equal to 35, and under root 36 is 6. So here answer will be 5.9. For 3 unpaired electron, 3 plus 2 5, 5 3 are 15, 16 is under root of 4. So here answer will be 3.9. So you can easily find out the magnetic moment of any of the element. For this you must know the number of unpaired electron. For this you must know the electronic configuration from scandium to zinc. And always remember, whenever we write the ionic state, the electron is always removed from the s orbital. That is, for example, if it is Fe, Fe is 4s2 3d6, and if we have to write Fe2 plus, so first electron from s orbital is removed, which means now the configuration will become 3d6. So if we discuss the trend of magnetic movement along the period, so as we know, number of unpaired electron first increases and then started decreases. So we can say magnetic character first increases, reaches maximum and then decreases. Now next important question, why d block element have a high enthalpy of atomization? Because they have a strong metallic bond. And now why they have a strong metallic bond? Because they have a large number of unpaired electrons. So these two are the key words you must mention while writing this answer. Similarly, manganese can show higher oxidation state Mn plus 7. Why this so? Because it has a maximum number of unpaired electron. It is 4s2 3d5. So when it loses all the 7 electron, it can easily form Mn plus 7. Now the higher oxidation is always exist in a fluoride and oxide only. Why? Because fluoride is highly electronegative and oxide also is highly electronegative. Now in comparison to fluoride and oxide maximum exists because it can form a multiple bond. So there are two answers for this. First thing, what is the common point between the two? That both are the most electronegative, but in case of and small in size, and oxide we can say exceeds the fluoride. Reason? Because it can form a multiple bond. So these two are a very important question. Again I am repeating, why higher oxidation exists as a fluoride? For example, MnO4, you can easily observe that higher oxidation can exist as in fluoride and oxide, and the reason behind, because they are the most electronegative and the small in size. Now out of fluoride and oxide exceeds the fluoride. So reason behind, for a plus 7 Mn required 7F, but in case of this it require only 4O. So as oxygen can form easily a multiple bond, so less atom required, so there will be less steric hindrance in that case. Why d block elements show the complex formation? So again two reasons. First is availability of d orbitals, so that they can easily accommodate electron donated by the ligand, and the second, they have a high charge on the transition metal ion. Because of these two factors, it can easily form a complex. Now important point, that why you can observe, you have observed in number of reaction that d block elements are used as a catalyst. For example, V2O5, nickel, platinum in hydrogenation. So why they are used as a catalyst? Why always transition element? So the reason, there are two reasons. First, they can easily provide a large surface area so that reactant absorbed on the surface come close to each other and facilitate the reaction. So basic reason is provide large surface area, and here it is the explanation what happened due to that surface area. Because on that surface area reactant easily absorbed and they can react easily. And the second important point, they can easily possess a variable oxidation state, so they can form number of intermediates and interchange their form. So there are two main reasons why transition element exists as a catalyst, because it provides a large surface area and it can possess a variable oxidation state. Why d block elements are colored in nature? Because of this dd transition. So you must write the electronic configuration. If d orbital contain an unpaired electron, it can easily jump from t to g to eg level and then just bounce back, and in that case the energy is released, which if falls in a visible region, then we get a corresponding color. So the one basic word for why transition elements show color, so that is because of dd transition, and it can be only possible when these orbitals contain electrons, or we can say which can easily jump from t to g to eg level. So if d orbital do not contain an electron, or if d orbital is completely filled, then they will be colorless. For example, d0 and d10, they do not show the dd transition, hence these elements are, or we can say these compounds are colorless. Next important questions, why transition elements easily form an interstitial compound? So because these contain voids, transition elements contain a voids, a space between the atoms in which smaller atom can easily occupy. That is, those interstitial sites are easily occupied by the small size atom like hydrogen, boron, carbon, and hence they can form interstitial compound. So there is an interstitial space which is present in transition element, which is occupied by the smaller element, hence they can easily form interstitial compound. Now important, you can if you have remembered that brass, bronze, stainless steel, all these alloys contain transition element. So now the question arises, why they can easily form alloy? So transition metals have similar atomic radii, they have a strong metal-metal bonding and high melting and boiling point. That is why they can easily form an alloy. So as we have discussed in the radius, that in between the series they have nearby same size because of the screening effect. So because of their similar atomic radii, they can easily form a strong metal-metal bonding and they can possess a high melting point. So all these are the important D block reasoning question. If you are able to learn this, I think you can able to answer all these questions in the exam.